cooked, or yeah, how's everyone feeling for the exam? Cooked, mega cooked, or like not too bad? So this. All right, so like 70%. All right, cool. Cool. Like 70 says like 70%, that's fine. Is anyone like super mega cooked? Is anyone like, you know what? And like don't be shy, don't be shy to say like, you know what, I actually don't know anything. Or is everyone like, all right, well, I'm like 70%. 70% is pretty good. Yeah, so don't be shy to like let me know how you're feeling. And I'm gonna so that way that will help me tailor how we're gonna go about this. That's gonna help me tailor if we're gonna start from the beginning, or is there anything that you guys want to see? Like, okay, I don't really get this, or I don't really get that. Yeah, so just let me know. And I'm gonna send myself this. And or another version of that question, what is the hardest thing for everyone? So what is gonna be the hardest thing that you feel like maybe not so confident in? Yeah, you know. All right, so 6 of 5 now. I think we're gonna get started now. So welcome, welcome. Yeah, feel free to either like comment. I'll check the comments. I'm assuming the audio is good. So if the audio is good, drop some thumbs ups. Let me know if that's all good here. The audio and everything good. Thank you, Tia. All right, perfect. Cool, cool, cool. So yeah, I think what we're gonna do then is basically kind of an overview, basically a crash course. Thank you, Isabella. And gonna start from the fundamentals, but we're gonna just go really, really fast. But if I go too fast, again, don't be afraid to ask any questions. And and we're gonna basically go through as much as we can, doing practice problems, test prep, things like that. Sound good? And as a matter of fact, I'm thinking we gotta even start with vectors, which vectors is gonna be super fundamental. Yes, this is gonna be recorded. Okay. All right, so it's 6 of 5. I think we'll get started now. All right, so again, I'm just gonna go through all the important topics. We're gonna do the equations, we're gonna do the examples, we're gonna do like as much as we can squeeze in. And we'll do any like traps and hidden things that you should look out for. So the first thing we have to basically talk about is vectors, right? So again, if at any point, just let me know if I go too fast or too slow or you want to see anything. And yeah, all right. And so here we have our coordinate axis, and then we're going to have our vector, which I'm going to define that as, let's say, A. Right off the bat, I'm just going to define that as R. Right off the bat, because the midterm's tomorrow, I'm just going to define that as R of t. Okay? So we're going to define R of t as the position vector. So this is going to be our first vector equation. And that's going to be, well, if this is at an angle, then this is going to be our first equation, really. And we're going to call that cosine of theta times r. Okay, and then r times sine of theta. Okay, so r is going to be the position. And then if you're wondering where did r come from, well, maybe you might see that as s of t. So the position vector tells us, the way I like to explain it, is if you're over here at Orbach, okay, and then you want to go to the hub, okay, and this is the hub. So the position vector, in this case, we have one dimension, right? So this is the x dimension. So the position vector is going to tell us, right, over time, how long it's going to take to get to the hub. Okay, so this is going to be a one-dimensional equation. And that's going to be in terms of our angle theta in 2 dimensions. And okay, or similarly, if you have a a rock falling down, then y of t will give you the vertical position over time, right? And then the angle theta will give us the angle. Okay, so with this we can derive all the equations here. So that's going to be the position vector, and then we're going to have our first true equation, which is going to be the velocity vector. So the velocity vector is going to be what? Okay, velocity vector is still a vector. So the velocity vector is still a vector, and it's going to be v of t equals the what? If I have basically a graph, if I have like a graph of, for instance, the position vector, what would the velocity vector tell us? Does anyone know? Let's say this is y of t. This is y on the axis, and this is time. And let's say that we're like falling down just like that. Okay. So if I get, so does anyone know what the velocity vector will be? If I get the rise over run, okay, of this graph, this is my rise, and this is my run. That's called the slope. So the slope of this y versus t graph, that's called the velocity. So this is going to be rise over run. And my rise is going to be delta r, okay? My run is going to be delta t, or we're going to call that the derivative, okay? Or that's going to be called the derivative. So right off the bat, that's going to be our second equation, right? Downward negative slope. Yeah, in this case, it's downward negative slope. In this case, it's downward. But in general, that's going to be the derivative here. Okay. So that's going to be our first equation right off the bat. Okay. And so, cool. So let's write that one more time. I'm going to say that that's v of t equals delta r over delta t. So that's going to be our velocity vector. Oh, let's see what Serene said here. Slope of position. Cool, 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 cool. So I think everyone's getting that so far. So again, if you have any questions, let me know. Then let's say I want to solve for r. If I want to solve for r here, what is delta, by the way? So does everyone understand delta? So what is going to be delta? Delta x equals what? Or delta y equals what? Or delta r equals what? Does everyone understand delta? What's delta going to be? So for instance, delta x would be what here? Delta x would be, well, that's going to be x what? X final minus x initial, right? And then y final minus y initial. And then r final minus r initial, right? Is everyone comfortable with delta? So that way we can plug in our delta x or delta r here. And we're going to get our first kinematics equation. So if everyone's comfortable with delta, let me know. And then if you're confused, okay, thank you, Tia. Thumbs up from Tia. Thank you, thank you. So then we basically have, well, that's going to be delta r equals v delta t. Or I can just solve that as r final minus r initial equals v delta t. Or, okay, r final, or r of t, rather, r of t equals r initial plus v delta t. Okay, and this one is going to be I like to call this one equation 0. Okay, this is going to be equation 0. That's how we get our first kinematics equation. And hopefully this looks familiar. Okay, because this is the equation for what? This is the equation for what here? So R is basically a line. This is basically y equals mx plus b, right? Because this is the slope of a line. And so the slope here is the velocity vector. That's going to be our slope. And then time is always on the x-axis. Time is almost always on the x-axis. That's going to be time. And then your intercept is going to be RB. That's going to be the initial position. Okay? So back to our person. If we have you're at Orbach, but then your friend is at, I don't know, the library. So you're at the library and then they're at something closer to Orbach, like Pierce, right? So if you're at Orbach and then your friend is at Pierce, they're gonna have an extra initial position here. Okay, so they're gonna be ahead. They're gonna be ahead of the curve. Okay, so that's gonna be represented by a line. So for example, they might ask you something like this. Okay, so maybe we have y1 is kind of like this, and this is going to be y1, and then we're going to have something like this is going to be y2. Okay, so between y1 and y2, so pop quiz, between y1 and y2, which one has the greater slope? Does y1 have the greater slope or y2 have the greater slope? Let me know. Okay, exactly, right? Okay, good. 2. All right, so 2 is going to have the greater slope. Good, y2. So that's going to be the greater slope. So then that means the velocity for y2 is going to be the greater slope for y1. Okay, so that's going to be the velocity or the speed. That's the slope. So I like to call this one equation 0 because that's going to be our first kinematics equation. And then we're going to have 3 kinematics equations. Okay. So this one's like a pre one that you don't really need this one unless they ask you like some card related questions kind of thing. All right. But then, all right, any questions here? Any questions so far here? Okay, so V2 is greater than V1. Nope, all good. All right, cool. So then that's the basis for everything. Once we have our position vector and we have the slope, okay, we're going to repeat that process for our position vector and our velocity vector, and we're going to have acceleration. So if you've taken calculus, then hopefully you know this. We have the position vector is going to be r of t. This is going to be the position vector. So if you take the derivative once, you get the slope, okay? So that's going to be our first derivative. You get the slope, so that's going to be r v of t, which we've been talking about. So we're going to take d dt once, okay? And that's the first derivative. And then if you take the derivative again, what are you going to get over here? What are you going to get on this side here? So this is going to be in meters. And then what are going to be the units here? And what are going to be the units over here? Okay? So we get to take the first derivative, we get velocity. So what are the units for velocity? And then what are the units for the second derivative here? Okay, so this one's the slope, first slope. This is just the first derivative slope. So what are the units here? And then also, what are the units here on this side here? So v of t is our first equation. V of t equals dr dt. Okay, does anyone know? So if this is slope, okay, if this is rise over run, so rise is meters and then run is seconds. So that's going to be meters per second. Okay, so this one's going to be meters per second. Meters per second. Okay. What about on the right hand side here? So what's after speed? What's after velocity? So if this one is meters and then this is meters per second, what's going to be the slope here? What's going to be the next one over here? Okay. So you take the first derivative once, you get velocity. Does anyone know what happens if you take the derivative again? There you go. Perfect. Acceleration, meters per second. Good. All right, awesome. So that's going to be acceleration is meters per second. So acceleration is going to be a of t, and that's going to be meters per second squared, rather. Meters per second squared. Okay? So the equation for acceleration is the slope of velocity. So that's going to be the slope for velocity. So if you have another graph, slope for velocity, that's going to be this graph here. Okay? Cool. So then if this is like, now this is v, okay, this is v and this is time. So same idea here. This could be now, this is now going to be v1, v1, and then this one's going to be v2. So now the accelerations are going to be different here. Okay, so now the acceleration for this one is going to be lower than the acceleration for this one. Okay? So let me know if we're still so far so good, or if I lost anyone here. Let me know if we're so far so good. Drop a thumbs up. Or if anyone's getting a little bit confused. Okay, cool. All right. So thumbs up, thumbs up, thumbs up. All right, cool, cool, cool. So this is the basis of everything. So I really want you to understand that that's going to be the slope, because then he can ask you like, oh, I don't know if there's going to be like a graph or like a slope. Okay, I don't know. But the most important thing is now that we have this equation, we're going to get our next equation. So that was everything already with vectors. So we're already done with vectors. Any questions about vectors before moving on? We kind of just ran through everything about vectors here. Okay. I don't know if there's any questions about vectors. So now that we have vectors, now that we have all the equations, we're going to basically do kinematics. So you need 3 equations. Kinematics. So does anyone know the 3 equations for kinematics? Okay. We're going to have 3 equations here. The first one is actually coming straight from over here. So if you want, next time I can show you how to go from here. And this is actually equation 1 for kinematics here. So equation 1 is going to be, that's going to be V final equals V initial plus A delta T. So this one is like, they're the same equation. Okay, this one is like let's call it the slope form. And then this one is called like the linear form. Let's just call this the linear form. Okay. Now, when we define our vectors, because we have also said that these are vectors, okay, now we're going to define them in terms of their components. So for every vector equation, okay, another small pop quiz for everyone. So this one's going to be equation 1. For every vector equation, how many components are we going to have? For every vector equation, how many components are we going to have? TSS2. Very good. And what are those components going to be? So we're going to have 2 equations. So I highly, highly, highly recommend you take your vector equation and then you break it up into 2 components. So what are those components going to become called? What's the first component? Okay, cool. All right, awesome. Isabel says X and Y. So perfect. So good. So we're going to have our X component, and then we're going to have our Y component. So that's how you know, because like sometimes people ask me like, oh, how do you know whether to cancel out something? Well, that's how you know, because you're going to start to cancel it out based on whether it's 0 in the X or in the Y. So for example, often, for instance, right off the bat here, often AX is going to be 0, okay? AX is going to be 0. So not always, but often, AX is going to be 0. So really, we turned that first component into Vx final equals V initial X, okay? So that means that the x component is the same. Okay. And then what about for the y component? Okay, let's write that in the y component is going to be v final y equals v initial y plus a y delta t. So what is a y often in the y component? Often, what do you usually replace a y with here? So how can we typically rearrange this? Exactly, okay, cool. We're going to replace that with our g is a negative 9.8 in the y hat direction here. So that's our gravitational constant here. So in other words, instead of memorizing this funky equation, might as well just replace it right off the bat and say VFY equals V initial y minus GT. So this is still equation one, but this one's way more useful because now we replaced it. And notice that why is it negative? Okay, why is my G negative here? Why is my G negative here? Okay, so this is still equation one, but it's just in a more useful form here. So what does the negative indicate? So if like a ball is falling down, right? Maybe you don't exactly downward acceleration, okay? So that negative indicates downward acceleration due to gravity. Okay, cool. So that's going to be equation one, and this one's probably the least useful of all the three kinematics equations because we have um we have uh like this one is not really useful, and then this one is not really that useful because this is typically going to be zero. Okay, cool, cool, cool. So what's the next equation here? What's going to be the next kinematics equation? Equation number two. What's going to be the next kinematic equation? So this one's probably the most important one out of the entire list of every equation. What's going to be this equation number two here? Okay, we're going to write that as our vector, right? Not I. Okay, delta t plus 1/2 a t squared. Let's just call that a t. All right. So this one, okay, equation with constant acceleration. All right. Cool, cool, cool. So this one is the equation for, yeah, constant acceleration is going to be the equation of a parabola. So this one's really, 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 really important. So we're going to be doing lots of examples with this one here. So remember what a parabola looks like. And let's go ahead and so every time you see like this, break it up into the two components. So if you're not sure how to break it up into the components, make sure you do your x component here, x, okay, and then y, and then I'm going to do my x one here, x final equals x initial plus vixt plus 1/2 axt squared. And often ax goes to 0. So here's a shortcut. You can save a lot of time because often ax goes to 0. So we can just say that's going to be the x final equals the x initial plus vix. So we turn a vixt. So we turn the second equation back to the very, very first equation we said. We said that this was the equation of a line. Okay. So we turn our equation 2 back into an equation of a line for the x component. Okay. So make sure you box this one. Okay. Often ax goes to 0. All right. And then what about the y version? So the y equation, I'm going to do the same exact thing. I'm going to say that this is y final equals y initial plus viy times t. And then again, I'm going to do minus 9.8 minus 9.8 1/2 g t squared. Okay. So again, a g is going to be a negative 9.8. Let's just make that positive. So I'm going to make this one a positive 9.8 because that's going to be our negative g here. So that's going to be minus 1/2 gt squared. So this one is the equation of a parabola. So you're going to use this one if it says, Johnny throws a rocket at an angle of, 30 degrees and travels, this many feet. That's going to be your delta x. Okay, so you're going to use this equation if you see Johnny is throwing a rocket at an angle theta, and then that's how you know we need to use equation 2. Any questions about equation 2? So far, so good. So far, not losing anyone yet. Okay, all right, cool, cool, cool. All right, so then what's equation number 3? So remember, this is still equation 2, but it's only in the x direction. Okay, so let's call this one equation 2x. Let's call this one equation 2y. So it's still equation 2, but it's only in one direction here. Okay, and then similarly here, this is still equation 1x. This is still equation 1y here. Okay, so what's going to be the formula for equation 3? Okay, equation 3 is going to be, what's going to be that here? Okay, VF squared, okay, equals V initial squared plus 2A delta R, okay? So again, don't write it in that funky vector form, break it up into the components. So break it up into the x component and the y component. So the x component is typically not useful because we're going to see that we have VF squared equals VI squared plus 2A delta x. But as I keep saying, this A is often 0. AX is often 0. So that's not really useful. But the one that is typically really, really useful is this equation here, because we have VF y squared equals VI y squared. Again, minus, so this is going to be minus 2g delta y. And delta y is h. Delta y is going to be often h. So this is going to be useful if you have Johnny drops a ball from a cliff. So Johnny drops a ball from a cliff at a height, and then so let's do our first example. Let's do our first example. I think there's one on your homework or something like that. So Serene is standing on the cliff here, and Serene is gonna drop the ball. Okay. And let's say that I have, let's see, and then the Serene drops a rock from the cliff, and we measure the time it takes is 3 seconds to fall all the way to the bottom of the cliff. Okay, so it took 3 seconds to get from the bottom of the cliff. So we want to know the height of the cliff. We want to solve for delta H here. We want to solve for H, which is the delta Y here, right? So how would we do this? Okay, so we have a person that is on the cliff, and then the ball is dropped downward, right? The ball is going to start to accelerate due to gravity. Okay, so this is where sometimes like you can be overwhelmed. There's all these equations. We have this equation. We have this equation. Okay, we have this equation here. So first things first is to always start with what you know and draw it if it's in 1 dimension or 2 dimensions. So if it's going downwards, it's going to be in 1 dimension here. So we're only going to be in the y dimension here. So right off the bat, we can eliminate anything with an x here. So we don't have to worry about any of these, okay? We're only going to focus on this y1 and this y1 and this y1, right? Okay, so the problem is we don't have the um, we don't have the initial velocity, right? So how do we know the initial velocity? what is going to be the initial velocity? So if you just like drop the ball, exactly, okay, if it drops from rest, it's 0, okay? So often the initial velocity is going to be 0. If you just drop the ball, then it's going to be 0 here, okay? So therefore, okay, therefore we can use equation 3. Okay, we're going to use equation 3. So let's write down equation 3, right? We're going to basically say VF final y squared equals V initial y squared plus 2a, we're going to say minus 2g delta y. Okay, so um, but our delta y is basically an h here. So that's going to be a negative h here. So we already said that this is going to be 0. Okay, this is going to be 0. So let's write that one more time. We have VF y squared equals negative 2g. And then we're going to put a negative h because our delta y is our y final minus y initial. So that way we have two negatives cancel out. So we have vfy squared equals 2gh. Okay. So the problem is we have g and we don't have h. We're trying to solve for h, but we're missing v final. So how can we get v final? So that's when we're probably going to need another equation. We're probably going to need the second equation here. So if you're not sure which one to use, just try a couple different ones out. So for instance, we might say that the final one is 0, this one is our h, this one is 0. So as a matter of fact, we actually don't need this one at all. We're going to use equation number 2, actually. So we're going to use equation 2 instead. Okay, so equation 2 in the y stated that y final equals y initial plus VIY minus 1/2 GT squared. So which of these can we cancel out? If we have the person dropping the ball from a high H, which of these can we cancel out and which of these do we know? Always write down what you know. Always write down what is the terms that you already know in the system. Does everyone know? So we already said that VI is going to be 0 because it started from rest. So this is going to be 0. And then this is really going to be the initial. That's really going to be the height. That's what we're trying to solve for. What about y final? Do we know y final? So if this is y initial, and this is y final, well, isn't that on the ground? So exactly, it's on the ground. So if it's on the ground, that's just going to be 0. So if I say 0 equals h minus 1/2 gt squared, I'm going to say h equals 1/2 gt squared. And I already know g is 9.8. So I'm just going to approximate that just for today, but obviously you're going to use your calculator. I'm just going to approximate that to 10. 3 squared is 9. So it's basically going to be approximately 10 divided by 2 is 5 times 9 is approximately 45. Okay, so Serene is 45 meters up the cliff. Okay, so that's how we use the equations. Making sense? Any questions here? So this is the general this is the general procedure for any problem, right? Even though it could be any system, it could be like this is how you do it for any problem. Wait, why couldn't we use the first equation again? Let's see, could we use the first equation? So if we have the first equation, then let's see, we have v final y, okay? Then because we don't have velocity. We don't have velocity here. So if we had velocity at the end, we could use the first equation or equation 3. So the problem is we don't have velocity. So, but now we can solve it here. Now, if there was a follow-up where it said part two, all right, calculate the velocity. Now you would use this h, okay? You would use this h, plug it over here, and then you would take the square root of both sides, and you can solve for velocity. Okay? So sometimes you need one equation, sometimes you need multiple equations to go from one to the other here. Okay? So yeah, it's just gonna take practice. Okay, it can feel overwhelming, but once you do it enough times, you realize it's not that overwhelming. You just break it apart. Okay, often the most important ones I want you to focus on are equation two. Equation two is super important, and then equation three, super important. You understand equation two and equation three. Okay, I see the correct equation only use initial v. The initial v was a 0, right? Making sense? Okay. So how are you feeling about kinematics? Pretty good? Or do we need some more examples? Let me see if we have more examples here. So then let's see. I want to do, so I want to do, I want to get all the equations down. I want to get all the equations down because then that way you know what to do in case um, you have that. So another version is if we say, Johnny is throwing the ball, then at an angle, then it's still going to be equation 1, 2, and 3. It's still going to be kinematics, but it's going to be 2D kinematics now. So 2D, remember, 2D kinematics is not different than 1D kinematics. So I forgot to mention that in our vectors. So let's go back to our vectors. So if I have, for instance, initial velocity, okay, this is what myself included. I used to always confuse this. If you have a velocity vector here, v here, this is your initial velocity, and it's at an angle, okay? Don't say that it's the length, it's not the length of the triangle, okay? So this is going to be the velocity vector, but it's not the length of the overall triangle, okay? So for example, if Johnny throws, or like let's see if Tia throws the ball at an angle theta, right? So Tia is going to throw the ball at an angle theta here. And then let's say I give you the initial velocity here. So this is the initial velocity. Um, let's say this is the initial velocity is, 3, the initial speed. Okay, let's talk about this because this one used to always confuse me. So initial speed, VI, we're going to say is, I don't know, 3 meters per second, right? Okay, so this is not the same thing as getting that distance though. Okay, so then let's say they throw that for a total of, 100 meters, okay? So this is a total distance over here, just like that. So this whole parabola here, let's say it's going to be, yeah, over here. This whole parabola, this is our delta x. Okay. So our delta x, this is 100 meters. Okay, but some of you sometimes, again, by some of you, I'm really projecting, I'm talking about myself. So I thought that this delta x here was right over here. So I said this is a little delta x is a little, right? Okay, no, that's wrong here. Okay, that's wrong. You're not going to say that the triangle is delta x. We need to solve for this delta x here. Okay, so how do I get the x component of this vector? Okay, let's say the angle is, I don't know, 30 degrees. Okay, so how would I get the x component of this vector and the y component? Super important. Everyone gets this down. Okay, how do I get the vx and the vy? Remember, vx is not 100. That's the first thing I want you to realize. Vx is not 100. Okay, so do not say Vx is 100 meters. That's the distance, that's the total like length here, but how do I get my actual Vx component? Okay, how do I get my actual Vx component? Yes, very good. Okay, Vx cosine theta. Okay, does everyone understand that? Vx equals VI cosine theta. Okay? So cosine of theta is 30 degrees. Okay, and then the VI is 3 meters per second. Okay, remember it's SOHCAHTOA. Does everyone remember SOHCAHTOA? So this is from the Pythagorean theorem. So let's do a side note. I forgot to mention that in the beginning. So this is A and B, and this is C. So what's the Pythagorean theorem? What's the Pythagorean theorem? Okay, don't forget your trigonometry here. Okay, don't forget your geometry here. So what's the Pythagorean theorem going to tell us? Okay, there you go. Exactly right. So a squared plus b squared equals c squared. Okay, a squared plus b squared equals c squared. So right now, and then we have sine of theta. Sine of theta. So what's sine of theta? And what's cosine of theta? So what's sine of theta for our triangle here? And what's cosine of theta for a triangle? Okay. Okay, just because you're done with geometry doesn't mean you can forget your geometry. Just because you're done with trig, okay, you're doing a lot of trigonometry here, okay? Don't forget your trigonometry. Okay, sine of theta is gonna be what? The sine stands for what? How do we memorize the angles? So sine, right, is so ka toa, right? Okay, perfect. There you go. Okay, cool. So sine, so opposite, right? Opposite over hypotenuse. Okay, so exactly right. So sine of theta is opposite over hypotenuse. So that's how we get Vy over Vi. Okay, so the hypotenuse is your initial velocity here. Okay, so that's how we get sine. And then so if you want your sine one, that's going to be your Vy. And then your cosine is going to be your what? What's going to be cosine? Adjacent. Perfect. Adjacent. So Vx, which is your adjacent, over Vi again. Okay. So super, super, super important. You guys practice this. Okay. There's going to be sine from SOHCAHTOA, opposite over hypotenuse. Okay. Cosine is adjacent over hypotenuse, right? SOHCAHTOA. And then if you want to get your angle, then you're going to use tangent. So tangent is how you get your angle is going to be opposite over adjacent. Is going to be Vy over Vx. Okay. All right. So yeah. Cool. Any questions here? Okay. So that being said, all right. So that being, let me wait if there's any questions here. So that being said, we got to go back to our kinematics equations. Now we have to rewrite all the kinematics equations in terms of the angles all over again. But here's a trick. Once we have our Vx and we have our Vy, well, that's already in the kinematics equations again. Okay. So I'm going to erase this because I ran out of space here. Okay. So I'm going to rewrite equation 1, 2, and 3 for x and y. So here's your x equations and here's your y. Okay, so for the x one, we're gonna say that vi, we're gonna say that v final, okay, in the x direction equals vi in the x direction, but that's just vi times cosine of theta plus a delta t in the x direction. So that's equation one. And then similarly, for equation two, you're gonna say that the x final equals the x initial plus vi initial cosine of theta plus a x delta t squared. Okay? And then equation 3, we have v final squared equals vi squared cosine squared of theta plus a delta x. Okay, so I'm not doing anything different. All I did was just tack on this cosine of theta. All I did was I just tacked on the cosine of theta. But you'll see that these are the exact same equations that we've been going over. These are the same kinematics equations that we've been going over. So if you need to get your kinematics equations, all you need to do is simply, don't freak out, okay? Don't freak out. All you need to do is just simply tack on that cosine theta term. And then what do you think we're going to do on the right-hand side for sine of theta? Oh, I just gave it away. I'm going to add on, right, sine of theta for the y term. is going to be y final equals yi sine of theta. We're just going to make that a minus minus gt because that's gravity. Gt. Y final equals y initial. Oh, that was a VIY, by the way. VI sine of theta. This is VI sine of theta. VI sine of theta. This is yi plus VI sine of theta minus 1/2 gt squared. And then V final y equals V. Okay, so if you break it down like this and you practice it, you see you have to just practice it. Okay, you can't just memorize the formulas, chat. You have to actually practice that. Makes sense? So this is minus 2a delta y. Okay, and this is going to be sine squared. Erase that. Vi final squared, sorry. Vi squared sine squared theta minus 2a delta y. Okay, so we rewrote literally the exact same equations, but all I did was tack on my sine of theta for y and my cosine of theta for x. Okay, so y, think of sine, and then x, think of cosine. All right, so that way you can plug in all the equations here. Any questions there? Okay, really, it takes a ton of practice. It's just gonna just practice, just lock in tonight, chat. Just lock in, practice each one, every single equation, and answer every single problem that you have. Okay, and then very quickly running out of time, so I want to get to the other equations as well. So that's gonna be 2D kinematics. Any questions here? All right. So yeah, if anything, these are pretty much all the equations you're gonna need, like for kinematics at least. If anything, this is like your nice little cheat sheet here, because sometimes cosine, that's just gonna be one, that's gonna be one, that's gonna be one, or like this might be zero. So these 6 equations, this can work for pretty much anything. You're just gonna have to just cancel out here. Okay, so for example, if there's no horizontal acceleration, you're going to make that 0. If there's no initial velocity, you're going to make this 0. If it lands on the ground at the end, you're going to make the right hand side equal to 0. Okay, so these ones are like really good because that's going to help you save time and stress. All right, then we gotta go faster, chat. We're running out of time quickly. So we gotta do exponential decay. So the key word is going to be exponential. So as soon as you see exponential, well, you're just going to write down your 3 equations. So you have delta x equals v max, okay, times t minus tau, okay, plus tau e to the minus t over tau. So that's equation 1, where your v max is equal to t times a max. So the key word here is exponential. So if the phrase says blah 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 exponential, then you go boom right to this equation number 1. And then for velocity, which remember we said was the first slope, was going to be v max, which you can plug in from your tau, remember a max, and that's going to be 1 minus e to the minus t over tau. Now, if they don't give you a max, but it's decreasing exponentially, well, the initial is your max because that's the highest it's going to be. So if you peaked in high school, then that's all you get. So that's your initial. That was your max. Okay? So that was your VT is really your initial velocity. Okay? And then same for acceleration. So again, if you peaked, then that was your initial. That was all you get. It's all downhill from here. So good luck there for the rest. Okay? And that's going to be your initial max because it's going to start off. So it's not going to say, oh, it has a maximum velocity. It's going to say it has an initial velocity, but that is your max. So that's how you plug that into your second equation here. Okay. And then lastly, for your third equation here, is going to be A of t equals A max, okay, e to the negative t over tau, okay? So that's going to be, again, so it's not going to say, oh, the maximum velocity, is going to say initial acceleration. So the keyword is initial. And then tau is just the ratio, okay? Tau is just the ratio, so you're going to check both of those graphs. So that's how you're going to calculate tau. And you're going to calculate tau and then plug it in over here, over here, over here, over here, and over here, okay? So all of these have tau, which tau is a constant. Okay, tau is a constant, which you're going to solve from equation. This one was called equation A. You're going to solve equation A for that constant, tau, and then you're going to plug that in. So when we solve for the question above, do we do x and y independent from each other? Exactly, you're going to do x and y independent from each other, okay? And then that way you can plug it in. So often you're going to solve for like initial velocity or like time or whatever it is, okay? So that's going to be your exponential functions, your kinematics, okay? Any questions here? It'll be an exponential function. So like, for example, let me see if we have a quick example real quick. Okay, let's see. So let me get this quick. Let me see if we have an example here, chat. It's basically going to be, okay. So I'm looking for the one that says exponential. Okay, so this one here. So a cheetah starts from rest. Okay, a cheetah starts from rest here. So let's get this one here. Okay, this one's good. So a cheetah starts from rest. All right, so a cheetah starts from rest here with an initial acceleration of 7 meters per second here. So let me cut this here. So let's see if I can bring that back. Nope. Okay. So it's going to be an initial acceleration here. Okay. So it says a cheetah starts from rest here, accelerate with initial acceleration of 7 meters per second. So this is what I mean by initial. So we don't have any equations that use initial here, but it says initial it says A max here. So this is A max here in equation 3. So the key word here is initial acceleration here. And it says gradually reaches a top speed of 30 meters per second. So during the process, its acceleration decreases exponentially over time. So that's the key word here. So decreases exponentially here, decreases exponentially. That's going to be your key word here, decreases exponentially. So that's going to mean we got to use equation 3. But the problem is, and then it says, what is the acceleration after 3 seconds? So we have t equals 3, but the problem is we don't have tau. So we got to use this equation to get tau. So from equation A, we said V max equals tau times A max. And again, they don't give us a max, they give us initial. So initial is our A max. So A max equals 7 meters per second squared. And then let's see, gradually reaches a top speed. So that one is V max equals 30 meters per second. So I'm going to solve for tau equals Vm over Am. And then that's going to be 30 over 7. So whatever that number is, that's like going to be approximately 4 point something. And then now I have tau, which remember, now I got to back plug that in over here. Okay, so now I solve tau using equation A. That way I can plug that one into equation 3 here. Okay, does that make sense? So now I plug that one into equation 3, and I have t equals 3 seconds. So at the end of the day, my answer is going to be A equals A max, which was 7 times e to the negative. So, and then make sure you know how to use exponential on your calculator, chat. So it's going to be negative 3 over 30 over 7. So to use exponential, does everyone know how to do exponential on your calculator? So you got to do exp. So you're going to do 7 times, whoops, 7 times exp. So on mine is going to be, let's see, I have second exp here. So that's going to be that one here. So second exp negative 3 over 3 over 7. So negative 3, and then don't forget your parentheses here. Okay, 30 over 7. Okay, so I got 3.4. Okay, I got 3.476 here. So I got C here. Okay, I got 3.5. Okay, so let me know if that was too fast, but I'm just going quickly here because I'm already recording this and you can review what I did here. So notice how I broke. So again, I broke it down. Okay, I broke down what we do have. Always start with what you have, and then I plugged in the equations, equation to get tau here and to get AFT. All right, cool. So that's going to be exponential functions. Now, any questions about exponential functions before moving on? All right. What else do we have here? Yeah, we have all the velocity. We talked about that. There's one more thing that I skipped that I didn't realize we had last time. And then we're going to end it with Newton's laws for the rest of the hour. So then the last one we're going to do is Newton's laws. And then, yeah, basically now we're going to move on to Newton's laws. Okay, so it's been about an hour. So that's pretty much all of acceleration. Okay, that's pretty much all of acceleration. I mean, kinematics. And then for the rest of it, we're going to focus on Newton's laws. Okay, Newton's second laws. Okay. All right. So last chance for kinematics here. So again, it's going to take practice, chat. It's just going to just do it over and over again until you can do it in your sleep. Does that include the forces and those equations? Does that include the forces? What do you mean? So Newton's laws is going to be forces. Yeah. Yeah. So we're basically done with like velocity and stuff. And then the rest of the hour, let's focus on like forces. Yeah. Yeah. Is that what you're asking me? Like kinetic. Exactly. Yeah. That's going to be forces. Exactly. Right. Yeah. That's going to be Newton's laws. Okay. So cool. So the first thing we're going to talk about is Newton's second law. This is like the most important equation. Newton's second law. So what is Newton's second law? So what is Newton's second law, and like what can we, yeah. So what is Newton's second law, chat, and like what do we do with it? How are we going to use it? How are we going to use Newton's second law? Okay. Don't be shy. Just let me know what's the equation here. And then I want to double check that we have everything here before moving on real quick. Yeah, I think that's everything. Okay. All right, cool. Yeah, F equals ma, right? All right. So let's start there. F equals ma. So, um, well, if we just have like this form, that's just going to be 1 Newton equals, well, that's kg times meters per second squared. Okay. So what I want you to realize that's the most important thing here is not it's just not just F equals ma, right? It's basically it's going to be F net. So let's write it like this. Let's write it like F net. Because everyone's so worried about the right-hand side, but then you forget about the left-hand side. So everyone's so worried about the right-hand side, but you forget about the left-hand side. So the left-hand side is going to be the total. This is the net. This is the net, right? Total net force on the system, right? So, and we're going to go case by case, and we're going to go quickly. DT says, would you be able to go over deriving the projectile range formula? All right, we can do that if we have time. Projectile range. Oh, I knew I forgot something. Yes, chat. I knew I forgot something. I forgot to derive that. Okay, let's go back to kinematics real quick because I forgot where that is. Yes. Okay, projectile range is we gotta derive it from here. We gotta derive it from here, but I really suggest you kind of memorize it. Okay, one more thing for kinematics, and then we'll go back. Okay, thanks for that. One more thing for kinematics. And we're gonna derive the way it basically comes out. It comes out from equation 2 and 3, I believe. We're gonna use equations 2 and 3. So if we have time, we're gonna derive it. But for now, I just recommend memorizing a chat. So memorize or should we just try that now real quick? Let me just see if I have it. Yeah, it's gonna be delta x. It's gonna be this equation. This is gonna be projectile range. Projectile range. Delta x equals v naught squared times sine of 2 theta divided by g. Okay, this is gonna be your projectile range. So um the way that comes out is from equations 2 and 3, I believe. So we can get our delta x, vi cosine theta. Yeah, and then we'll get our vi from vi squared here, I think. And yeah, you're gonna combine this equation and one of these two. I forget which one. And you would combine those to get this expression here. So if we have time, we'll get that final derivation. Okay? But for now, I just recommend you just memorize that in case you don't have that. Okay? All right. So let's continue here, F net here. So we gotta go case by case here. So we gotta go case by case. And so same idea, like just because we're done with the previous chapter doesn't mean you can forget. Doesn't mean you can forget your kinematics. So the first one here is gonna be case one. So case one is going to be a box on a plane. So let's write this down. Okay, box on a plane. So case one is going to be basically we have a box, okay, and this box is static, so there's no acceleration here, but we have to draw a free body diagram. So what are the forces on the free body diagram? What are the forces on the box here? Well, we have gravity here. So gravity is going to be a force. Okay, cool. Normal force. Exactly, right? So normal force is going to be equal and opposite to gravity. So when we use our F equals a ma equation, we say acceleration equals 0 because it's static. It's in static equilibrium. And so we're going to say the gravity is going to be only in the y direction, and the normal force is only in the y direction. We're going to set that equal to 0. So we're going to get basically ny minus mg equals 0 for the y direction. So therefore, that's how we've shown that the normal force is equal to mg. Okay? So that's case one, box on a plane. So you have to, again, draw the free body diagram and get those total forces. Okay? Any questions here? That's case one. Can you explain how you got mg? Oh, because force of gravity is called weight. So, and then weight is not the same as mass, but weight is, well, that's going to be mass times acceleration, but the acceleration is due to gravity, so that's going to be m times g. Okay, so that's called weight. So when we talk about like how much do you weigh, you're actually talking about weight versus mass compared to weight versus mass. How do you know when to do the normal force, like pushing the ramp box to the cart? So how do you know is going to be equal and opposite? So Newton's third law. So what is Newton's third law, chat? So what is Newton's third law? Okay, what is Newton's third law going to be? So let me know what is Newton's third law. And then we're going to do that next one they said. So put like the pushing the ramp back to the cart. Okay, I think I'm going to do case two. So what is Newton's third law, chat? So Newton's third law. Okay, cool. Yeah, for every action, there's an equal and opposite reaction. So that's going to be Newton's third law. That's called the normal force, right? Equal and opposite reaction, exactly, right? So what if we have on box um box like box on a plane with tension, right? With tension without friction. Without friction. You know what? Should we do friction? Let's just do without friction and then we'll include friction. So we're still gonna have box on a plane here. Okay. Here's our box, and then here's our plane, and then we have the gravity here is gonna pull that down, right? So first things first, we have to draw the free body diagram. Okay, I don't know when you hear this, but you're not drawing the diagram. You're jumping into the equations without drawing the diagram. You really need to draw the diagram. So if you're jumping into the question without drawing the diagram, how are you gonna know what to write the equations? So draw the diagram. We have the box here is pulling that down. That's still the same. That doesn't move. Okay, respectfully, right? Respectfully. And then the normal force is pushing that up. But now we're going to have a pulling force is a force applied here. I'm going to call that tension. Okay, so the tension here is now, that's now at an angle, right? So now the angle here, I can define that as, right? That's going to be our angle theta here. So again, just because we're done with the last chapter doesn't mean you can forget about your geometry here. So that's going to be that angle here. And that gives us T is that side. All right. So we're going to ignore friction for now. And now it's going to start to accelerate. All right. Which direction is it going to accelerate, chat? Which direction is it going to accelerate? If we have these three vectors here, which direction is it going to accelerate? Okay. And I'm going to write my Newton's law again, which says that F net equals MA. And then I'm going to break that up into my X. Okay. Break it up into your X and break it up into your Y. So for my X component, that's going to be what and what. So what are going to be my components here? Okay, so if the box is standing still, right? If the box is standing still and then I'm pulling it with tension, okay, then that's going to create what? That's going to create what? Okay. So now the normal force is going to be slightly less. Now the normal force is going to be slightly less. So I'm going to do the Y one first just to show you. That's going to still be 0. Okay, so it's still going to be just like last time. Remember we said positive n in the y direction minus mg, and then we're going to say plus what? Plus what equals 0? What is this going to be here, chat? So we have three vectors. So what's going to be my first vector is my normal force that's going up. Down is negative. Okay, down is always negative. Down, good, plus t. Okay, but all right, you're really close. Okay, but this is going to separate the A students from the B students and the B students from the C students. So you said plus T. Okay, I'm really proud, but you do need something here. You do need something exactly. Okay, so we're gonna use our T. Now, is it gonna be sine of theta or cosine of theta? So if we're in the Y direction here, now we have this one is the Y and this one is the X. Okay, so how do we know if we need sine or cosine? How do we know if we need sine or cosine? Well, remember, don't forget SOHCAHTOA. SOHCAHTOA. So I'm going to do SOHCAHTOA. So which one is opposite? Which one is going to be our opposite? Yeah, opposite is vertical. Exactly, right? So that's why we're going to do T sine of theta. Perfect. Good job. T sine of theta. Okay. So that's going to be our first equation. And then I put it equal to 0 because there's no acceleration. So I put it equal to 0 because there's no acceleration here. So then, like that's how we can get that equation, and then you can use that. So there's no acceleration. So you need sine because opposite, right? Does everyone see this is opposite? Here's our theta, opposite. Okay, it's like opposite, just like that. And then this is the adjacent side. This is the adjacent side. So don't confuse your opposite with your adjacent, and then don't forget to tack it on. So if you forget the sign, you're gonna get it wrong. If you use cosine, you're gonna get it wrong. Okay, and if you don't include it at all, you're gonna for sure get it wrong. So you need to get not only tension, but then sign. Okay, super, super important. And don't worry if you don't get it right away. Okay, don't worry if you don't get it right away, but just keep practicing it every single day until you do get it. All right. So then on the left-hand side, well, all I see is I have t, now I'm going to say t cosine theta equals ma. I'm going to say t cosine theta equals ma in the x direction. All right, so perfect. So I can actually solve for my t here. So I can actually solve for my t here and then plug it in over here. So I can actually solve for my t here is max over cosine of theta, and then that's going to be what I can plug in over here on the right side as well. Okay, so it's going to be box on a plane with tension with friction here. That's case 2. And then let's see if I have one here. Let's see if I have an example here. Okay, any questions about this one? I want to do the hardest one that you're going to have on your exam. I want to do case 3. That way we can finally do some more examples for the last 30 minutes. We're going to do case 3, finish up Newton's laws in 5, 10, 15 minutes, and then we'll do examples, as many as we can squeeze in. Okay. Wait, so it's ma because there's no other force that causes it to equal 0. In the x direction, there's acceleration to the right. Correct. So the acceleration is like pulling it, right? The acceleration is like pulling it to the right. So it's gonna start to accelerate. It's gonna start to move horizontally in that direction. Making sense? We still so far so good? And for y, it's because there is no other force that causes equal to 0. And for y, it's not going up or down, exactly. It's not gonna, it's like if imagine if I like dragged a box and then it started floating up. Like it's not gonna start floating up, I just dragged the box. I'm just dragging it to my direction here. So that's exactly why. So it's not gonna go up or down because you're not dragging it, okay? And then cool. So now I want to do case 3, which is the hardest one. So case 3 is going to be basically everything. Okay. So case 3 is going to be box on an inclined plane. Okay, box on an inclined plane with friction and with tension. And with tension. Okay. Okay. Cool. So with friction and tension. So make a really big one, chat. Make a really, really big triangle so we can zoom in on it. Draw a really, really big triangle. And then we're going to go ahead and do our box here like so. And then here's our box. And then here's our angle theta above this. So they're usually always going to give you this angle theta. Okay. And then to make it harder, you're going to have a tension force pulling it over here. And then let's say he's nice. Let's say he gives that to you. Okay. And then let's say this is M2. And let's say that this is M2 is like, let's say he gives you the masses. So he might say M1, and then he might say this one's M2. So he might say like, M1 is 5 kilograms, M2 is 10 kilograms. Okay. So step 0, before you do any equations, you don't do anything. You can't start until you draw the free body diagram. Like I cannot emphasize it enough. Draw the free body diagram. All right. So now we have a couple options here. What do you think we have to draw in here? If we have 2 boxes, how many equations, how many free body diagrams do you think we have to draw if we have 2 boxes? This is box number 1, okay? And this is box number 2. Exactly, we're gonna need 2 equations. So this one's gonna be easier because we're just gonna have M2G going down, and then this tension force is pulling that up, okay? And then that tension force is gonna be equal to M2G, so box 2 is really easy. And then this tension force is gonna be pulling it to the right because, okay, whoops, all right. So if box two is greater than M1, right? Because M2 is greater. If M2 is greater than M1, Which direction will the box slide? Will box 1 slide? Okay, so if M2 is greater than box M1, which direction? Okay, which direction will box 1 slide? Up or down? Up or down? Mm-hmm. Up and to the right. Okay, good. So then there's going to be a tension force here. Therefore, which direction will friction be pointing? So I'm going to call this tension here, which we already know is M2G, so we can already solve that. But which direction is the friction force? Which direction is the friction force? Okay. Okay. Opposite to the direction of motion. Okay. Opposite to the direction, exactly. So friction, right? What is friction, chat? Friction is like if you rub your hands together, right? That's gonna cause some friction. So if the box 2 is pulling it to the right, then box 1 is gonna go this way here. So that means tension is gonna resist that motion here. So we're gonna have our gravity pointing down. We have our gravity is pointing down. And then we have our tension is going up to the right, and then we have friction, which is represented by a little f. And then, last but not least, what's the fourth vector we're going to include? What's the last vector we got to include on the box? What's the fourth vector? Exactly. Okay, normal force. Cool. Good job. Good job, everybody. So now we have normal force is going up here, and then friction is going down. Okay, now, all right, so here's the hard part. So now we have the free body diagram. We need to do, okay, before you even start freaking out, just write F equals ma, right? F equals ma. So is acceleration 0 or non-zero? Do we make it equal to 0 or non-zero? Is this in static equilibrium or dynamic equilibrium? Comment down below. What is it? It's gonna be static equilibrium? Exactly, okay? Non-zero is dynamic, so we're not gonna cancel out the right-hand side, so we have to expand the left-hand side. So this is F net. So if we have um 4 vectors, we gotta have 4 terms. If we have 4 vectors, we're gonna have 4 terms. I like to do it in terms of the vectors first. If you want to jump right into it for x and y, that's fine. But I like to do it in terms of the vectors first. So I'm going to say we have gravity first. It's like gravity, tension, friction, and normal force. Okay? So if we have gravity is pulling down, we have tension is pulling up, we have 4 vectors, so we have to have 4 terms. Okay? We have 4 vectors and then 4 terms. Is it dynamic because of friction? It's dynamic because box 2 is pulling this down, and then that's gonna pull this box 1 up. So the reason it's dynamic is because box 2 is, yes, creating tension on the system. Okay, it's creating tension, is gonna pull that up the plane, right? All right, and then this is the hardest case. I don't even know if you're gonna have this, but this is like the hardest one. So if you can get this, then you're solid for all of them. Okay, because this is gonna be the hardest one here. So same thing, chat. We're gonna break it up into the x component and the y component. So that way you don't have to think and be freaking out tomorrow. You just go one by one, start doing gx, okay, plus tx plus fx plus nx equals ma in the x direction. And then you're gonna do gy plus ty plus fy plus ny in the my direction. Okay, so normally we cancel out our gravity here and for the x direction, but we're gonna make it a little bit more complicated. But actually, it's gonna make it easier. Okay, so right now this is at an angle, but like I can't rotate it. So like you take your image and you change your frame of reference. So now like you kind of rotate it. So now when I'm looking at it, it looks like it's flat now. So now what I see when I'm looking at my paper, it looks like the box is like flat on the plane. Does that make sense? Let me pause there. You rotate it so that the way the box, in my perspective, now it looks flat. Okay? Let me pause there if everyone understands that, if that's confusing. So like I rotated it here, so I'm changing my inertial reference frame. So I'm gonna call this one y. I'm gonna call this one y prime. Okay, and I'm gonna call this one x prime. So that way now it looks like it's kind of flat. like this. So this is x prime, and this is going to be x, this is going to be y prime. Okay? Does everyone understand what I'm saying? I'm kind of like looking at it like that now, so that it's like, okay, I can like, the box is like flat on the plane in my new inertial reference frame. Okay? Because now when I do that, I can cancel out tons of forces here. So now I'm going to bring down this gravity here and then draw this component as a right triangle like that. Let me take a pause here because this one always, like, it took me forever to understand this. It took me forever to understand this. So let me take a pause here to see if people get this part. Is this making sense? Okay, so I basically rotated that. Okay, Tia says yes, thank you. So I basically rotated that. Then my box is at the incline. Okay, and then now I have my new. Okay, so now this is going to be only in the x direction. So that way, why did I do that? So that way now I don't have any tension in the, like for example, look at tension here. I don't have any tension in the y direction or friction. So that way I can cancel out all my tension here and friction in the y direction. Okay? And then similarly for my n, I don't have any n in the x, so I'm going to get rid of that one n in the x. Okay? So now that actually made it easier now. So now I have these terms, and I'm almost done. So what do I have to do? Okay, what do I have to do next? Why isn't the g negative? Okay, I knew someone was going to ask that, and that's why I said I like to write out in terms of all the vectors here, and then I'm going to define g as negative in a second. Okay, so I'm going to make g negative mg. So in other words, my g, I made it positive because I'm going to make it a negative mg y hat. Okay, that's a really great question. That's a really great question. So I did it general because like I don't like to think, right? I don't want to think about if it's positive or negative. I just want to generalize it here. And then now I'm going to make it negative. Okay. All right. But before I do that, this is the hard part here. Okay. By the way, oops. I was going to ask y'all. So where's my theta here? Where's my theta? So this is a similar triangle. This is a similar triangle. This is a big triangle. And then this is a little triangle here. So this is my 90-degree angle here and here. Okay. And you can prove, you got to prove it to yourself geometrically. You can either prove it to yourself or you just memorize it. So just memorize, chat. Like I always thought like, oh, this is my right angle and then here's my theta. Nope, that's wrong. That's not your angle. You have to like flip it. You have to like flip it here. So my angle is going to be where? Now my angle is going to be up on top here. Now my angle is going to be up on top. Okay? Does that make sense? Is there a difference between G and G when written? Or formulas says two different things. Oh, your G is your, we got to do gravitational. So yeah, little g is 9.8, and then capital G, we'll talk about capital G right now. So hold that question for a second, Aditi, because capital G is different than little g. We're gonna do that one next. Okay, but Chad, let me know if that makes sense here. So this was our angle down here on the left here, and then this is now up on top. It's the same triangle here. Okay, because that took me forever to get that. So that took me forever to understand that. So now that's tricky here, because now if I want my gy here, now this is my gy. So now what do I do? Do I do sine or cosine? Do I do sine or cosine here if I want gy? Would we always put it closest to 0, 0? Um, yeah, it's always gonna be whatever's like touching here. That's gonna be your theta. So you're like this is like your 0, 0, right? So it's always gonna be touching that theta here. Okay? So that's gonna be your um theta. Okay. And then cool. Then lastly, we're gonna do is we're gonna start to plug that in. So this is gonna be my gy now, and this is gonna be my gx. So now this is where I plug in my negatives here. So I have a negative because that's my negative gy, and this is gonna be negative gx. So this is where I'm gonna plug it in here. So now I'm gonna put negative mg, but for gx, do I use sine or cosine? For gx, do I do sine or cosine? Exactly. Now we're gonna do sine of theta because it's opposite. So this is opposite. So gx equals is gonna be negative mg. We're gonna do negative mg sine of theta. So we're gonna plug that one over here. So that took me forever to get that chat. That took me really, literally forever. Minus, okay, and then what's the friction force? What's the equation for friction here? Almost done here. What's the equation for friction here? It's going to be basically minus mu what? Mu times what? It's going to be equal to mgy now. So what's my gy? Well, this is my adjacent side. So this is going to be my, okay, mg is going to be negative mg cosine of theta. Okay, cool. That's going to be my mu mg cosine of theta. Okay, mu mg cosine of theta equals ma. Okay, and then finally for my y, we have negative mg sine of theta plus mg cosine of theta equals may. Okay, so that's going to be our two equations. So this one is for the x, and then this one is going to be for the y. I think this is the hardest case that they could possibly ask you. I don't even know if you're going to have this. So if you can do case 3, then you can do any of them because this is the hardest one here. Okay, so hopefully I did that right. That's basically going to be our 3 cases here with the blocks on the incline. Okay, blocks on the incline going downward due to gravity. Okay, making sense? Making sense? Almost done here, almost done. Let's just do one more final equation. We gotta do 2 more. We gotta do 2 more equations and I think we're done. So, and then we'll do questions or whatever people want. Oh, why is fx mu g? Then it would become mg cosine theta. So fx, so the friction is the one over here. Friction by definition is the normal force. So it's the mu times the normal force. And then the normal force is only this one here. So it's kind of like, how do I explain this? The friction is tied to the normal force, but the normal force is tied to the mg cosine of theta here. Okay, so does that make sense? The friction is tied to the normal force, and then it's going to be tied to that one. Okay. The way is fx equal mu g, then it would become mg cosine theta. Yes, cosine theta. Okay, they equal to each other. Yeah, they're equal to each other here. So this one is going to be, this one's basically going to plug into here, and then the normal force is going to plug into here. Okay, because the friction is a function of the mass. It's a function of the gravity. Okay, so all right, almost done. Okay, so each if it's on the y-axis, even each if it's on the y-axis. I want to say that again. So on the y-axis, yeah. All right. What was that final question? Mm, okay, I'm assuming that we're good here. So I'm going to do a couple more equations here. I'm assuming that we're good. If you have any more questions, let me know. So the next one we got to do is just drag. So I don't think we really have to talk much about that one. So drag is just going to be if you have like free fall, like if a guy is falling with a parachute. So that's just pretty much, you just need that. Okay. If you want, you can set that equal to mg because that's equal to gravity. So that's going to be equal to m times g. That's equal to gravity. And then you can solve that, or you can multiply this by 2 and then divide both sides by CD rho A. So CD is a constant. So he's going to give you CD as the drag coefficient, Okay, A is the cross-sectional area. Cross-sectional area. So he's going to give you this. He's going to literally say cross-sectional area. And then rho is the density of air. Density of air. Okay, so then I can cancel out everything and then leave it on both sides. So then I'm going to get v squared. If I want to solve for the terminal velocity, is going to be mg over, I got to divide both sides by Okay, 1/2 CD rho A. Okay, so that's going to be 2mg CD rho A. And then I take the square root of both sides, so then I'm going to get what's called the terminal velocity. So the terminal velocity means that that's going to be your maximum falling speed. So eventually skydivers, they reach terminal velocity, so you can't fall any faster because now the air is pushing back faster and faster here. Can you explain what each part of that equation stands for real quick? Yeah, so that's that. So CD is the drag coefficient, so he's going to give that to you. And then cross-sectional area, density, and then B is the velocity. Yeah, so it's the same thing as terminal speed. Yep, it is because it's the square root. So um so speed and velocity, they're different. Speed is a scalar, velocity is a vector, but in this context, speed and velocity are the same because we're going to take the square roots. Okay, so it's the terminal speed. So if you see, okay, the person has a terminal speed, then that's going to be your like instantly go to this equation. If you see drag coefficient, drag area, cross-sectional area, okay, go to my drag equation. Okay, I don't think I want to talk about this one. I don't think I want to talk about this one, but any questions? The last one I want to talk about is gravitational, and then we'll have like about 20 minutes for questions, like like examples or whatever you want. Okay. So the last equation we're going to do is Newton's law of gravitation. So that's going to be if you have a body here, this is the sun, and then this is the earth. So this is the mass of the sun, and then this is the mass of the earth. Okay, and then you look up the distance from the earth to the sun, and then you look up the mass of the sun and the mass of the earth. So and so then we're gonna have Newton's law of gravity. Newton's law of gravity. So Newton said that F, right, equals negative G m1 m2 over r squared. So this is going to be basically like like okay. So if you have the mass of the sun in kilograms and the mass of the earth in kilograms, okay, then that would be our total constant here. Now G is a constant, so they would give you this is what I mean. So they would give you that, they would give you this, they would give you R in meters. And then G is a constant, so you got to memorize G, which is what? What is going to be G, chat? What's going to be G? G should be, okay, 6.67. I guess you got to memorize this. 6.67 times 10 to the minus 11. All right, and that's going to be newtons per meter squared per kilogram squared. Okay, so you're going to always plug that's a constant, plug that in here. Okay, and cool. So now the cool thing about this equation, let me know if there's any questions there. Yeah. You have an equation sheet, 6.67 times 10. All right, perfect. So the cool thing about this equation is still going to be F equals ma. So if I have F equals ma, then I can set that equal to the right-hand side, and then that's going to be our mass. So I can solve for ma here, and that's going to be my m times g. So if I cancel out ma, let me make that a g. That's my little g. So if I do G equals a capital G divided by M over R squared, okay, then this is my formula for the gravitational constant. It's going to be my gravity here is going to be G over M, G times M over R squared. So what we're going to do, which I think maybe he did that already, but we have the mass of the Earth. If you say the mass of the Earth is 5.97 times 10 to the 24 kilograms. And then the radius of the Earth, basically the radius of the Earth, okay, is going to be, let's see, I want that in meters, okay? So it's going to be, radius of the Earth is 6.371 times 10 to the 6, okay, meters. then I'm gonna plug these ones in to that equation. And I already have my G, my capital G. So someone go ahead and let me know what you get. So someone go ahead and calculate that out. Let me know what you get. So I'm gonna plug in my 6.67. Let me know what you get here. What should you get? What do you think you're gonna get? Newtons per meter squared times kilogram squared. That's going to be my capital G. And then my mass is 5.97 times 10 to the 24 kilograms. Don't forget the parentheses, chat, okay? There's going to be 6.37. Don't forget the parentheses. This is times 10 to the 6 meters in parentheses quantity squared. All right, let me know what you get here. What's going to be that question here. So what is the wait, so for this type of question, what could he possibly ask us for? Like he's gonna say like what is the gravity here? This is what I want you to get here. This is what I want you to this is what I want you to see. So then if you calculate this out, you're gonna realize what this is for. You're gonna realize what this is useful for. So what should you get here if you multiply that all out? Okay, so don't forget to do this calculation here. Remember, this is the G term is 6.67 times 10 to the minus 11 times 5.97 times 10 to the 24. Okay, divided by, all right, 6.371 times 10 to the 6. Okay, that's going to be a meter squared. And then this one squared, let me know if someone gets that. I'm going to cancel out my meter squared. I'm going to cancel out my meter squared. All right. And then let's see here. I'm going to cancel out one of my kilograms. Now, if I have basically, okay, so now I'm going to have newtons per kilogram. And a newton is a kilogram times a meter per second squared. Okay, per kilogram. So I'm going to cancel my kilograms. So, anyone calculate that out? If you get that out, what are you going to get? You're going to get G equals, oh, interesting. This is going to be 9.81. That's how you get that 9.81 meters per second squared. So that's where that 9.8 comes from. As we look up, we have the mass of the Earth. That's going to be constant. Okay, so we have that. You calculate that out, try that out. All right, and cool. So what he could ask you is like calculate for like the moon. So like the moon is going to be like a little bit different. You're gonna have like less gravity on the moon, right? Because there's less attraction there. And like he'll have to like give you the mass of like the moon and the radius of the moon or the distance between the Earth to the moon or something like that. And cool. Cool. I think we finished, for the most part, all the equations that we could. So we still have about 20-25 minutes left. What's the last thing we should do, chat? What's the last thing we should focus on for the next several minutes? Should we do more examples? Should we do more like clarifying? What should we do to make the most of our last few minutes? He will provide all the necessary constants. Yeah, he has to. Yep. So I'll give you all the numbers. Can you show example of static and frictional coefficients? Okay. So for static, let's see. I think I wonder if I have one for static. Let me see if I remember one for static versus friction, kinetic. So let's see. Let me do kinetic first because I remember kinetic right now, but I can't remember static at the moment. So kinetic will be like a person is going like on with socks. They like they're wearing socks and then they like start sliding um with an initial velocity. Let's say, you know, v naught vi equals, you know, 3 meters per second squared. Okay. And okay, so then we gotta go all the way to the right hand side. So they're like running here, they're running, and then they start sliding here. So they're like running, and then they start sliding here. You know, it's gonna say like a person is like running, right? And then they start sliding here. So you're gonna call this x equals 0. And then they're gonna start sliding here. And you know, they might either give you the distance or they might ask you to calculate the distance. I wish I had like a specific example for this one specifically. So I would just recommend checking your book or something like that. Um, but the way that this is going to work is you're going to do a force balance and then just turn your person into a box. Just turn your person into a box. That's going to make it way easier. Okay. So if I turn my person into a box, then I'm going to only have gravity is pulling that down. As gravity is pulling that down, and I'm going to have normal force is pulling that up. And then one thing that I really want you to understand is if you identify what type of problem it's going to be, that's going to help you to alleviate your test anxiety. So if you figure out, all right, what type of problem is that, that's going to alleviate your test anxiety here. Okay. So like I know this is a Newton's second law problem, so that's going to help me figure that out. Static and coefficient, friction coefficients. How do we do a following question? That was on the question. All right, got it. All right, I'm going to check that one out next. So let's see if this one is gliding. Okay, so maybe let's do that one. Yeah, maybe let's do that one. So it says, all right, so I'm going to do that one that you dropped in the chat. So it says a 60-kilogram snowboarder is gliding on flat snow at a speed of so we have a person is gliding on flat snow at a speed of 4 meters per second. After 6 seconds, her speed decreases to what? Her speed decreases to, okay, 3.4 seconds. Okay, so this is telling me we're going to use acceleration because in the very, very beginning, remember I said acceleration was delta V over delta T. All right. Assuming only the horizontal force acting is kinetic friction, which that makes sense because it's only going to the left. What is the coefficient of kinetic friction between the board and the snow? All right. So again, we got to do our force body diagram. So I only see something in the x direction. So I see my kinetic friction is going to the left, and then I see my static friction is going to the right here. Okay. No, rather, no, my kinetic friction is going to the left, but my velocity is going to the right. All right, so I'm going to do F equals ma, and do F equals ma, okay? And then I have something to the right here. And so my acceleration is going, actually, acceleration is also going left here. And my only force is friction. So friction equals ma, okay? Only in the x direction. So friction is equal to ma. So what's the equation for friction, chat? What's the equation for friction here? Friction equals what times what? Okay, friction is going to be mu, perfect, all right, times mg, all right? So that's my equation for friction. And then that's going to be equal to, so I'm going to say mu mg, that's going to be equal to m times a. And then what do we have to solve for? It says, what is the coefficient of kinetic friction? So I need to solve for mu. So I gotta solve for mu here. I'm gonna solve this one here. I can cancel my m. I don't need mass. And so I'm just gonna say that mu times g equals a times x. And then mu is equal to a x over g. So that's my equation. Now I have g, but I don't have a, but I can solve for a. How am I gonna solve for a? So A is delta V over delta T. So A is going to be 4 minus 3.4 divided by 6. So it's going to be approximately 0.6 divided by 6, which is about 0.1. So I'm going to plug in my, let's see, is that right? 4 point, calculate that out here. I have 4 minus 3.4 divided by 6 is, yeah, 0.1. So now I'm going to plug in my 0.1 over here. So I have my mu equals 0.1 divided by 9.8. Okay, I'm going to take 0.1 divided by 9.8. So I got 0.01. I got 0.01. So I got A. Okay? So I got A. So I did that. So see my thought process, chat? I draw the picture. Okay, step one, I draw the picture. Step one. Draw the free body diagram. Okay. Step two, I did Newton's second law. Newton's second law. And then step three, I solve the equations. Okay. In this case, we had an extra step 4, which is going back to kinematics. Okay. But if you break it down like that, always start with what you know. Always start with what you know is always going to draw the free body diagram. Draw the picture, and that's going to help you do less thinking. Makes sense? Less thinking, and then you're gonna increase your chances of getting it right. If you're overwhelmed and you're thinking like, oh, I don't know what to do, I don't know what to do. Okay, all right, break it down. Start with what you know. Start with what you already have in the problem given in the problem statement. So we already know how to draw the picture, and then that's how you're gonna break it down step by step. Okay, it's gonna take practice. Always, 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 always gonna take practice. Okay, so that was that one. Yeah, so if you guys have questions like that, you can submit. Just like let me know here. Okay. And then Hooke's law. So for Hooke's law, that's typically going to be like energy though. So Hooke's law, yeah, that's the one we didn't really talk about Hooke's law. But Hooke's law is basically going to be negative kx. So I mean that might just be equal to like m times g or something. So um what can we talk about Hooke's law without making it too complicated? Okay, because like with Hooke's law, that's going to be basically you're going to have to use energy here. So I don't even know if this is the right chapter. I don't even know if you're going to have Hooke's law or Reynolds number. Yeah, same for Reynolds number too. Like that's like a different that's like a different class. Okay, Reynolds number is rho v d over mu. So that's like a totally different class here. So the density here is the density, the rho is the density. So it's literally going to say the density of water. Okay. The mu, or he used eta, that's called the viscosity. That's called the viscosity. So he'll give that to you. And then the velocity, this is the speed. This is the speed. That's just like regular speed, meters per second. And then the L, okay, he said L. So that's the length of like a pipe. Okay. So all of those should be given. Okay. And all right. On average, how long should a question like this take on this test to manage time? How many questions do you have on total, and how much time do you have? So that's how you manage your time. You take your total number of questions divided by the total number of minutes. Or you take the total number of minutes divided by the total number of questions. Okay, so 50 minutes, 15 questions. So that's on average 50 divided by 15. So that's only three minutes per question. So you only have 3 minutes per question. So you have to carefully manage your time and think fast. Think on your toes. If you're stuck, don't get stuck. Just like keep moving on. So do the easiest ones first. You need to buy yourself time. Don't do the hard ones. Don't do the kinematics ones. Save those for last. Okay, you need to do all the easy ones first. Okay. Should some be focused on for longer than others? Yeah, exactly. So some of them like do the easy ones first. Okay, so some of them are gonna be easier. So do those easy ones first. You're gonna buy yourself time and like like okay, I'm confident, right? I'm confident I can answer this in a minute. So every time you answer it in a minute, you're gonna save yourself 2 minutes that you can buy to answer the rest of the questions. Okay. So it's gonna be basically like a race against time, race against time. So you manage your time properly. 3 minutes is not a lot of time per question here. So you have to like really, really just rush yourself. Okay, but rush strategically, right? Right? Like you rush yourself so that you don't get overwhelmed, but balance out. Okay, all right, you know what? This problem's gonna take too long. I'm gonna skip it. Okay, I'm gonna skip it. Okay, and then yeah, I think that's my main takeaway, guys, is like you draw the picture. As soon as you draw the picture, that's gonna clarify everything. Okay, as soon as you draw the picture, then that's gonna clarify everything here. So like once again, like you know, let me just pull like a random one here. Let me just pull like a random problem here. Um, let's see. I really want to do. Okay, I really want to do this one where let me just give you this problem here. So it's gonna be a box with, let me see if I can find it here. Okay, I think I remember it. So it was like a box one here, and then this is box two. So let's just like do like a random problem here. And here's how this is the thought process that you have to do for every single problem, right? So if I have box one, this one's gonna be M1, and I think this was given as like, let's say this is 1 kg. And then M2, let's say this is like 2 kg or something. Okay, I think I found it here. Yeah, this is 2 kg. Okay, so there's a tension, and then there's also, so this is tension from a rope, and this is tension two from a rope here. Okay, and then this is acceleration is given here as 3 meters per second squared here. Okay, so we have two boxes here, M1, M2. Okay, so we have to draw the diagram, okay? So we need to solve for, we don't need to solve the whole thing, you just need to solve T1 minus T2. So as soon as you have an expression for T1 minus T2, okay, be done with it. So I'm going to select box 1 to start off, okay? I'm going to do my gravity, remember, draw the diagram. So I have gravity is going M1G, M1G, and then I have tension is pulling that up. That's tension, one. But I also have T2 pulling it down. Why? Because T2 is a weight that is dragging my box 1 down. So that's why I'm going to have T2 pulling up. So what kind of problem is this? So step 1, draw the diagram. Draw the diagram. I'm going to keep repeating it. Draw the FB diagram. Draw the free body diagram. So this is going to be a Newton's second law. So I'm going to write Newton's second law, which is F equals ma. Notice that this is literally exactly what we just did a second ago. We have F equals F net equals ma. So I already have A, and I already have M. So what am I trying to solve for? I need to solve for T1 minus T2. So now I need to do F net. How do I do F net? Oh, because I already drew the free body diagram. So once you draw the free body diagram, then I'm going to just plug that in here. That's going to alleviate my test anxiety and get a lot more focused, a lot more clear. So I have tension 1 is pulling up, minus T2 is pulling down, okay? Minus M1G is pulling down. Oh, equals MA. Oh, I already have M1. I already have M1 here. So I have that and I have that. So then I'm just going to add, okay? And then step 3 is solve. Okay, so I have T1 minus T2. I'm going to add M1A and M1G to both sides. And I already have M1 is 1 and A is 3. So I say 1 times 3 plus 1 times 9. Okay, so we have 3 plus 9, and that's going to be 12 meters per second squared. Okay, so we don't have to solve the whole thing. We don't have to overcomplicate it. Okay, some of these questions are going to be really, really well designed so that you can solve them in like a minute. Okay, and some of them are going to be really poorly designed that they're going to take forever to solve. So just skip those. It doesn't matter. Don't sacrifice all that time just to get a wrong answer when you can spend that time wisely to get the correct answer for the easier problems. Okay, it's always important to get the easier problems here. Okay, G is 9.8, right? Yeah, change that to 9.8, you know, make that a 10, make that like a 9.8. Yeah, I just rounded here real quick. And you can kind of round it too. Okay, you can kind of round it too. All right, so pretty much let's end it right about here. we'll like last couple minutes here. We're gonna end it in the next couple minutes. So last chance to ask your questions here. So last couple minutes here. And yeah, let me know how it goes. Let me know how it goes, okay? So I think now you'll have my email, and then you can always email me if you get stuck. Um, will the questions have key terms to help us identify the type? Exactly. So some of them, exactly. So some of them are going to have key terms. We talked about quite a few of them. So some of the key terms, for example, exponential. As soon as you see the word exponential, all right, that's going to be a exponential problem. As soon as I see forces or vectors, all right, that's going to be Newton's second law. As soon as I see the word gravitational or gravity or gravitational constant or distance, that's going to be a Newton's law of gravitation problem. As soon as I see like angle, like a ball thrown at an angle, boom, that's going to be my kinematics in 2D. Okay. And if I see like something with like acceleration, that's going to be my kinematics in 1D or 2D, depending on if there's an angle. So there's only about like 5 to 10 different types of questions. And a lot of them are going to be really, really similar based on that. So if an MCQ was rounded down and up, which one would be our answer if both are provided? Would it be a rounded higher one or the closest one rounded? Don't round until the very end, chat. Don't round anything until the very, very end, because you're gonna carry your error all the way to the end. So make sure the last thing you do is round. Okay, so it's going to be higher or lower. Hopefully it's not too, like, hopefully they're kind of far apart. It's going to be like 3.3 versus 3.2. All right, you're cooked. So then you gotta make a get educated guess there. But if it's like, 3 versus 5, you get 3.2, well, it's going to be 3. Okay, all right. So yeah, I pretty much recorded all of this here. So make sure you email me if you get stuck. Um, and then yeah, let me know when's and then if anyone's taking organic chem, let me know when's that so we can run it here as well for organic chem and do the same thing here. And yeah, so good luck to everyone. Thanks a lot for being here. I will be sending out this link, and email me or text me or DM me if you have any questions. All right. Good luck, everyone. Thanks so much for joining, and I'll see you on the next session. Peace out.